My name is Naresh Soni, and I am president of TiE South Coast. First of all, I want to thank Qualcomm. Qualcomm team has done an amazing job in putting this event together. Big hand for Qualcomm. My specific thanks go to Nakul Duggal, who made this happen. And also, I want to thank MIT Forum. We put this event together jointly, and it turned out to be an amazing event. So thank you, MIT. Also, I want to thank our speakers, our keynote speaker, Paul Jacobs. Nakul Duggal, Chancellor of UCSD, Pradeep Khosla, and our panelists, John Wall, CEO of QNX Software, Brandon Nixon from Lytx, and Patrick Little, SVP and GM of Qualcomm Automotive. Just a few words about TiE. TiE was quoted by Economist magazine as world's largest entrepreneurial organization. The mission of TiE is to foster entrepreneurship. We were founded in 1992 in Silicon Valley by successful entrepreneurs, and then it grew to 61 chapters in 18 countries across 5 continents. We have a unique program for also high school students called TiE Young Entrepreneurs, TYE, and these high school students are being taught at UCSD's Rady School of Business on taking their idea, developing a business plan, and then competing at local level, regional level, and global level. This year, our team won global competition. We have a great teacher in entrepreneurship by the name of Dr. Rob Fuller, and our team did so well that they won the global competition. Without any further ado, I would like to invite Nakul Duggal, VP of Product Management for Automotive at Qualcomm.
Thank you, Naresh. Can you hear me okay? Good evening. Thank you very much for this fantastic attendance. We will move quickly because I don't want to stand between myself and Paul. So we have a fantastic agenda set up for you this evening. A lot is going on in automotive. This is a space that Qualcomm's been involved in for some time, and the level of activity is almost daily, as I'm sure those of you that follow automotive have been seeing. The way that we look at this space is, there's been significant transformation in the wireless industry over the last 10 years or so. LTE, 5G is coming along, the whole smartphone transition. If you think about the auto industry, this is obviously a very different type of industry compared to what most of us have been used to. Daimler was formed in 1875, right, over 150 years almost. And these companies are traditional, very conservative, and they're being challenged by a number of different changes that are essentially coming from the mobile space. So what I think today's discussions are going to be about is, what do we see from our thought leaders as the transitions that are in front of us? If you think about the type of technology that cars are starting to embrace, from battery systems to display technology, from Bluetooth, Wi-Fi, modems in the car, the high-performance compute, all of this is essentially driving a variety of different use cases. We believe that autonomous vehicles in the future are going to need 3 key differentiators: the ability to navigate a vehicle, the ability to drive a vehicle, and obviously the human-machine interface. There is significant transition that is happening in this space in terms of what it means to own a car. Is a car something that will be owned as an asset, or does this become a service? So a number of different aspects that we will cover today, starting off with Paul's keynote. So I'll hand it over to Paul to kick off the evening for us. Needs no introduction, Paul Jacobs.
Nakul, I thought I was supposed to get all the pretty slides. Saw you had a nicer slide than me. How'd that happen? Gee. Well, thanks for the intro. Wasn't much of an intro, I guess. I don't need one, okay. Well, thanks everybody for being here. It's an amazing crowd. It's good to see everybody so focused on automotive and the opportunities ahead. And thanks a lot to TIE because they actually voted me a Lifetime Achievement Award. And when that came, I said, was that supposed to be for my dad? Because I didn't really feel that old for a Lifetime Achievement Award, but somehow it happened anyways. But thank you for that, and thanks for being here. And I will say thanks to MIT. My son went to MIT. My dad went to MIT. I went to Cal, so I tried to get my son to go to Cal. Bears? Yeah. All right. Good. Anyways, we got that all out of the way. Let me just, that worked. All right. Of course, everybody here knows Qualcomm, and we've had lots of discussion about what our vision was going forward. And really, for over 30 years, we've driven the evolution of mobile technology from analog to digital and smartphones to feature phones to smartphones. And we've kind of changed in that time the way people interact with the world around them, with each other. I mean, this is a story we all know, but it was one we all lived through as we were driving this technology. And there were a lot of times that people didn't believe that this was going to happen. I used to go to cocktail parties and talk about putting stuff into the phone, and people are saying, why are you doing that? I just want to make phone calls on it. And now we're talking about connecting our cars and connecting all of the stuff, all the things in the world around us. So the world is going to be like this amazingly connected place. And that's just commonplace to us. I mean, we just accept that now, that the Internet of Things is going to happen. And it's billions of devices and everything around us. And I think fundamentally it'll change the way that we interact with the world in ways we can't even imagine now. Much like when we first started to do email and use the internet, and now we look at how things have changed so much. And so Qualcomm's really taking this systems expertise that we have and now driving it from just connecting people to information and so forth to connecting everything. And I think that really will change so many things. But in particular, when I hold it up and I go like that, then it's not CDMA. So obviously we're changing the automobile, and you heard some of these different trends. There's so much stuff that's gone on in the car over the last decade, so much technology that's gone into the car, and we've really been there, putting connectivity into the car. I was looking back, and anybody remember Wingcast? Yes. A couple people. So in 2000, we had a joint venture with Ford on telematics, which only lasted a couple of years. It didn't really work out. It was, I think, a little bit ahead of its time. But then in kind of the mid-2000s, we really hooked up with OnStar and really got into the whole notion of connecting the car up. And we saw a lot of these opportunities ahead, and now it's really coming, it's coming home. I mean, I think everybody recognizes, you're all here because you recognize that. And it is these different kinds of things, these mega trends that are happening of having connectivity, but intelligent connectivity, of having the car be more and more autonomous as we get to the different grades of of ADAS, and the cars, more and more cars are electric cars. And then we're going to, as you heard, this notion of sharing economy and do you own your car, and sort of all of these things play together to interact and say, what is this trend? Where's this trend going to actually end up? And of course, we hear the negative stories now. Somebody using the systems a little too early, maybe a little bit too much overpromise of the capabilities of the systems, and then we have horrible accidents. And what I truly hope, and I worry about, having lived through Newton killing handwriting recognition, that we don't have so much overpromising here to the end consumer that we sort of hurt the industry going forward, because there is so much benefit that we will get out of these different trends. So I'm going to talk about the trends a little bit. And but let me just start by saying, as I said, we've been in this for quite some time, and we were really the first to put embedded LTE in the phone. We're the first to bring the high performance LTE into the car. I said phone, I meant car. We did hotspots in the car with Wi-Fi and Bluetooth. We've already shipped over 340 million ASICs into cars serving over 20 OEMs globally. So that's what's happened already. It is a big business already for Qualcomm. And why did that happen? Well, people talk about the phone as talk about the car as a smartphone on wheels. I'm not sure that's a little bit of an exaggeration, but certainly the electronics component of the car has gotten much, much more important. And all of this stuff that we did to drive cost, size, power, performance of capabilities going to the smartphone and leveraging a billion plus smartphone chips a year, all of that stuff has reduced cost, size, power, and increased functionality, and created this incredible array of technologies that now can be leveraged to make the car that much more intelligent and at really effective cost points, because it has leveraged the overall global smartphone market. So we have the interaction of the smartphone with the car, and we have the car itself having its own set of capabilities. And you can see it's just it's a very nice laundry list of stuff that we do that by providing modems, we do it by providing systems on chip, we do it providing connectivity, Bluetooth, Wi-Fi, location technology, all of these kinds of things that go into the car to create this opportunity for Qualcomm and the opportunity for the auto industry to make the car a much smarter thing. Anyway, so connectivity, it's intelligent connectivity. It's going to start as a foundation for all these connected car experiences. The estimates are by 2021, 60% of cars are going to have embedded cellular connectivity, and that connectivity is going to connect it to all sorts of stuff, whether it's to the cloud, whether it's to other things, so V to X, vehicle to vehicle, vehicle to infrastructure, vehicle to pedestrians. You probably do know this stat that I think the number came from 2014 that I looked up, but it was over 12 pedestrian fatalities a day from being hit by cars, and 30 times that of injuries that required a trip to the emergency room. Really amazing, astounding numbers, actually. So V to X, the vehicle to my smartphone as a pedestrian should create an awfully good, no, that's the wrong word, a very good change in these kind of statistics, and I think that's something to look forward to. Obviously, connectivity to any device that you bring into the car as well, so that you can share content. And I always love the idea. I have this screen, but I have all these buttons in my car. I want to use the buttons while I'm driving to affect my phone to put my content up on the screen. And when I bring my phone into the car should know that it's me and adapt and get preferences down and all sorts of controls to the different devices back and forth. And that's on its way. That's happening. The car and the phone will talk to each other and allow that to happen. Obviously, all this kind of intelligence also means that inside the car, we have these incredible graphics capabilities. So we used to have things where the UI would animate slowly. Now it's going to be beautiful like we all expect, because now we've just gotten trained that that's the way it has to be. So next. I don't know. So you guys want to check the battery on this, or? I got a second clicker. All righty. Anyways, I did have a nice looking slide. So anyway, so we were talking about moving sort of beyond basic safety and security in the car and the infotainment services to really give us more personalization, more convenience, more safety, authenticating the driver when you get into the car, getting access to all sorts of information. I mean, I don't know how many of you do the same thing. I mean, I have cars with pretty advanced systems, and I still actually use my smartphone in Google Maps and Google Navigation because it's got the most up-to-date traffic. But that's going to change as time goes on. And so all of this new stuff that goes into the car is going to make the car that much smarter, because it just seems so weird to me that I have this beautiful screen and buttons and all this interactivity, and I'm kind of looking down at my phone that's sort of in the cup holder there to figure out what the traffic is. But that's, this is all going to change as time goes on. And like I said, this whole notion of sharing content back and forth from the car to the phone and phone to the car, and the car possibly even being part of a content distribution system. So I get into the car and I can upload and download all sorts of information. And those kinds of things are going to happen. And then obviously just the interaction of a car to be able to have it park itself or summon it, and sort of get rid of the valet service. And all these kinds of things are going to happen with this intelligent connectivity that's going on. And there's really going to be this amazing information hub in the car, because today there's something like 60 to 100 sensors on board, and their engine and tire and brakes and the various closed loop feedback systems in the car. It's going to be hundreds of sensors going forward, and it's going to be all sorts of things in and around your car. And so you're really going to have a lot of information on the environment around you. You're going to have information on the driver. We just had a demo the other day of new very low power camera systems that you could put around the car and really monitor what the driver's doing, their state of awareness, where they're looking, all of these kinds of things that will come out of the investments that we've made in smartphones and be able to be embedded relatively low cost into the phones. We're going to have a great notion of that, and we're going to do a lot of sensor fusion as well between many, many different sensors that will be there, and we've already seen issues where an overdependence on one kind of sensor can lead to problems, but if you fuse among many different sensors, which the technologies and the compute that we're putting in the car allows us to do, you really are going to get a much, much better sense of what's around the car, what the state is, what the context is. And so that's going to be also fused with other data that comes off the internet, weather, location, time, date, all sorts of database information, high precision mapping, all of these kinds of things. And of course, the other insights that the OEMs get, manufacturers get, is how is that car working? And that was one of the things, actually, we had a conversation very, very early on with OnStar. I mean, I remember these conversations from a long time ago, over 10 years ago, about the notion of just what could you do if you could understand how the car is working? And that is just a natural thing everybody just assumes that now, that the whole fleet of cars will actually be monitored at all times. So all sorts of sensors that will go in there and give us many, many different capabilities and as we move towards self-driving cars, obviously these are absolutely critical things to have. This one works. And then, obviously, since it's Qualcomm, I got to talk about wireless. So, we have this whole evolution path in LTE, and really the connectivity in the car, that is the foundation. And by the way, I think it's not just going to be cellular. I mean, we're building a low Earth orbiting satellite system that'll deploy towards the end of the decade. and that will connect cars everywhere. And it's almost back to the future, because we did that with Omnitracs, where we put kind of a big satellite antenna on top of the car and on top of trucks mostly, because it was a more expensive system. And then the cellular networks got better and better, and that became less and less necessary. But there still are uncovered places. And so having satellite connectivity, that's also going to be an interesting path going forward. But the cellular connectivity is fairly ubiquitous, and it gets better and better. And the kinds of data rates that you can get, the kinds of different features that are going in, whether it's aggregating additional carriers, whether it's using unlicensed spectrum to get even more bandwidth down to the device. We announced a gigabit LTE modem now, so getting a gigabit to your palm of your hand, or getting a gigabit into your vehicle, in and out of the vehicle. So there's all sorts of capabilities coming there. Plus, the other thing that's going on is we're adding other features. So the ability to do broadcast over the LTE networks, the ability to do device to device with LTE Direct, and discovery, so that you advertise things that you're looking for or that you have, and the devices actually match those up and only turn on the high-level operating system and waste power when they know that they've actually got a match. So that's coming along. And like I said, the vehicle to X and these Internet of Things optimized, always on radio links. All of these things are coming, whether it's in LTE Advanced Pro, and so forth. And it just keeps moving. I mean, if you look at the different quadrants here of faster speeds, what are we doing to get higher and higher data rates? How many bands are now being supported because operators are just looking for more spectrum, and there's so much demand for data. We've sort of gone all around the world looking, where are we going to be able to put connectivity into? What spectrum can we use? So it's just more and more and more bands are being used. Obviously, voice, whether it's we've moved from circuit switch to voice over LTE, voice over Wi-Fi, high def, video, all of these kinds of things come into the car as well. And then all these different kinds of services that we're putting on. And we continue to invest heavily. I mean, we've invested over $42 billion in R&D to build these capabilities, primarily driven by the volumes of the smartphone market. But now, as we see IoT, all of those capabilities become available to everything else in the world, and at a very low cost. So we've been really trying to anticipate what are these big opportunities, what are the big challenges, and innovate the new technologies to go after those. And then, of course, that was 4G, and we like Gs, so 5G is next. And the thing that 5G is, though, is that it's not just more speeds and feeds. Of course, yes, enhanced mobile broadband, yeah. Fatter pipes, lower latency, better coverage, all those kinds of things that you would expect, just sort of a linear or better extrapolation of where we've been. But then the other things that we're looking at, and I think things that are critical for the car, is this notion of mission critical services. And I sort of challenged the team at one point. I said, well, just imagine if I was controlling my pacemaker from the cloud. I really, really want that link to be very reliable. But the same thing is true if I'm doing vehicle-to-vehicle connectivity for coordinated driving and the cars are not very far apart because we're platooning the cars. You really, really want to have low latency and high reliability. Or going back to that notion of trying to save pedestrians, you really, really want to know that you actually talked to all the potentially affected devices and people and infrastructure around. So this notion of mission critical services, along with a lot of security built into it, that's another aspect of 5G. And then obviously just going after the Internet of Things, ultra low cost, great battery life. So the ability to lock and unlock your car with a cellular radio, but to have that key last for a very long time before it needs to be charged. Very high densities of data. So we often talked about the data rates without saying where do you get that data, and is it data, is it megabits per second per unit area, now we think much, much more about those kinds of ideas of how much density can I have, because you take a crowded room like this and say everybody wants to upload something or download something simultaneously. That takes a lot of bandwidth in this room, and if it's a highly shared resource, then people get starved out, and we want to make sure that we fix that problem in 5G. And we're actually doing a lot of that in 4G, and 4G continues to evolve. So this notion of going from 4 to 5G, I think, will be a transition that's a little bit less abrupt. Of course, there will be marketing that says, boom, this is now 5G, and we know that Korea's Winter Olympics in 2018 and Tokyo's Summer Olympics in 2020, there will be 5G. My joke was always, I know when 5G will happen, I just didn't know exactly what was going to be in it when it happens. That will be because these particular events happen. But really, there is somewhat of a smooth transition through 4G to 5G. So anyway, so 5G is going to bring all sorts of capabilities to the car. More broadband, as I said, this very, very low latency capability for collision avoidance and synchronized driving, even enhancements in vehicle to X, to other things. And one of the cool demos that we've done already with augmented reality is the ability to put the goggles on and to be able to actually look through the car. So you're parking the car and you can look through the car and see the curb next to it. But imagine if I can look ahead and even through the car in front of me, because I'm using the camera of the car in front of me to see what's ahead of it, being transmitted back to me, and I actually see through that car to see what's going on up ahead. I mean, all of these kinds of things are going to happen. And then, like I said, this notion of the car as a node itself, whether it's for storing content, whether it's for hopping data back, whether it's for getting information from a car driving down the road the other direction that tells me what information it got from a car farther up ahead of me about what's going on there and brings it down to me and hops it to me. I mean, all of these kinds of things are going to occur with these new technologies. So exciting times. I mean, you may have heard people say there's no innovation going on. I hope we have disabused you of that notion, because otherwise I just go home. Anyway, so having this kind of capability with 5G and all these other capabilities really drive us towards this notion of greater autonomy, one of the other mega trends that I was talking about. And in the US today, the estimates are that 94% of car accidents are due to driver error. So the belief is that autonomous vehicles or increasing autonomy in the vehicle should dramatically improve highway safety. And I just actually, right before I came down, I was looking at a report from UBS that just came out that they had done a survey in terms of what consumers were willing to pay for this. And they were saying that consumers in their survey were willing to pay $2,000 a vehicle for more autonomy, which was a little bit less than maybe the cost of it right now. But what it means is people do see incremental value from it. So that's good. The other thing that people talk about is when is it going to happen? And we hear all these different stories about trials that are going on. I mean, personally, I think full autonomy might be a little farther out, but full autonomy in controlled situations, a gated community kind of model or something like that where there's more control, I think that will come significantly sooner. And all of this capability to get to autonomy requires a lot of the functionality, not just the connectivity to get the database information out of the cloud and sharing of information from all the sources of data that are connected around us, but it's those functions that have been built into the devices. High precision position location that's built in, computer vision technologies that we built for the phone that now get transported into the car and maybe even amped up because there's a little bit more power for more compute to be done, more sensor fusion with location technology, camera technology, radar technology, LiDAR I mean, all these different things come together. And so when we have 5G as a transport mechanism and all the other services and capabilities that go along with that, that will, in my mind, definitely accelerate the the ability for a vehicle to be autonomous. And then we're going to deal with some of the other issues, the non-technical issues that I think will be important as well. But this whole notion of vehicle to X, I think, is one of the crucial areas, and just the notion of all the different things that we can get, and using communications not just for communications, but also as an extension of the sensor network that's built into the car itself, extending it to all the other things around it and getting that sensor information from them allow you to do things, speed warnings to the curb from the infrastructure, the notion of the car ahead knows that there's a car coming, don't pass, and the collision warnings and platooning and all these things, and for San Diego with all the people that are out on their bicycles, the notion that I'll be able to detect and have something low enough power that'll be on my bicycle that can then talk to the car, so when the person's sitting there texting and their car's not fully autonomous, they don't run into me. All these kinds of things are underway, and vehicle to X, which we're spending a lot of effort in the standards bodies to try and bring forward faster, they really help a lot, and particularly help a lot in kind of non-line of sight things where just looking yourself or looking with a camera, that doesn't work. So having the ability to have communication and sensors at a distance, I think is going to be a critical component for autonomy as well. And then the other aspect of it is machine intelligence. We all know that our devices are getting smarter and smarter. We're using algorithms and technologies that are somehow derived from looking at biological systems in certain ways, and these are very, very complex things, so complex sometimes we don't even know what the system is doing internally to do its classification, but they work. I mean, objectively, you see they work. When you notice that you talk into your smartphone now and the voice recognition really does work under a lot of adverse conditions around it, that is because machine intelligence has gotten dramatically better, both in algorithms and the amount of compute that you can put at it over the last few years. And so having machine intelligence built into the car to analyze all the data that's coming from the sensors, that's coming from other sources around you, from the environment, from other cars and so forth, we have already been building these capabilities into the chips in the phone, and they will just get better and better and better as they go into the vehicle. And so doing deep learning and machine learning in the car, that will happen, and it will be combined with deep learning, machine learning that's going on in the cloud as well. And then the fact that everything is connected together will allow these things to be synergistic. And so, it's a critical component. It's an area that we've been working on for quite some time. So having that intelligence, machine intelligence in there is another big aspect. Okay, so let's move to electrification. So Tesla drivers, electric car drivers, not so many yet. Interesting. Hopefully that will change as time goes on. But it's true. I mean, it is the future of auto. It's a little bit of the presence. I mean, we're sort of edging our way into it. There's a lot of reasons why it hasn't taken off more. Range anxiety, although I have to tell you, for me personally, when I drive my electric car, which has been charged up every night, I don't have the range anxiety that I have when I drive my gasoline car, and I realize, I really should have gone to the gas station last night before I parked it because I got to get somewhere in the morning. I experience range anxiety in my gasoline car more than I experience it in my electric car. But anyways, that's something that people do worry about. Obviously, the cost of them, Tesla's trying to build a big battery factory. Having been involved in battery production myself at one point, this is a hard thing. And I wish him all the best in getting the scale up, because it's super important to drive the cost down. And we don't want to have electric vehicles really be dependent on government subsidies for so long. It's also this notion that, do I really need to do I really need to plug my car in every night? We all are sort of trained to plug our smartphones in. We don't really like it that much, but we do it. Plugging our car in is just another thing that you got to do. We definitely have been looking at solving that. I'll talk about that in a second. But the expectation is that plug-ins and plug-in hybrids, full EVs and plug-in hybrids, these things are going to grow from less than 1% of vehicle sales in 2015 to maybe greater than 6% by 2025. So those are sort of the guesstimates of where they're going. And we have the Formula E car up here, because that's kind of cool if you think about the fact that you get so much performance out of electric that we can build a race series completely around electric vehicles, and it's exciting, and there's so much torque that you get that there's probably more passing in a Formula E race than there is in a Formula One race. And the other cool thing is it's quiet enough that they can actually play music and announce the race while you're watching instead of having to wear headphones. So anyway, so that's sort of a cool far out aspect, and ludicrous mode on a P100D, you get supercar kind of performance. So performance is actually a pretty interesting selling point of electric cars as well. But I think this one pain point of having to plug the car in is something that we wanted to solve too. We started out by solving wireless charging for your smartphone, and we did it for our smartwatch that we did and for some other accessories. We said, well, this technology can get scaled up and actually be effective for cars. And there's really a nice bridging strategy there as well, which is I buy my car, that's a plug-in hybrid or full electric, and in my garage I put the mat down, and when I drive in it charges my car. And when we get enough critical mass of those cars, because I have the charging in my own garage, then the chargers will be in parking lots, and they'll be in other places, and eventually they'll be in the streets. So I believe that there is a path to see sort of continuous or intermittent charging going on while you're driving around. That will also help the range anxiety as well. And we've got a pretty good group of partners so far. It's still early days. What's kind of cool on Formula E with Halo is that you have the safety cars and the pace cars, and the safety car is sitting there, and when an accident happens, you want that thing out on the road. You don't want to actually have to unplug it. So it's there, it's charging all the time, and when it has to go, it's completely charged. So sort of an interesting aspect of it. We've built the technology now into a bunch of different cars, the i3 and i8 from BMW, Nissan Leaf, Honda Accord. So this is already happening, and I think this will be a critical component. Now, there's all sorts of stuff you need to do, like you really don't want the cat to go crawl on top of this warm mat, and you get my point. So we built a lot of safety into it as well. And the other thing that we did from our experience with the issues with cellular to manage the amount of absorption of energy by your body with cellular, we also applied that to these kinds of systems as well. So I think our system probably is one of the most tested in terms of that kind of safety regime as well. So also kind of an exciting thing. And then the last mega trend that we talked about was the sharing economy. And I would just say that it's sort of self-evident that this is related to smartphones. I mean, this is the way you summon your Uber or your Lyft or whatever. And it is the fact that you have all of that capability, the location technologies, and the great connectivity for the mapping, and all of that stuff built into something that you're carrying with you at all times that enables this kind of thing. And then we see, as I talked earlier, the extension of this to the idea that we might not even own our cars, that we might just summon them. And like I said, I mean, my sense is that will happen in controlled environments first, and then it will be more uncontrolled environments as time goes on. But there are some pretty interesting expectations out there. If you look at some of the numbers that people are projecting in terms of by 2030, 1 in 10 vehicles are expected to be a shared vehicle. And that's a pretty dramatic change to the business model of the industry. But I think in the end, Qualcomm will play a part in both the smartphone side or whatever other device it is that you're using. And and of course, build all these technologies into the vehicle as well. And that's going to enable this whole sharing economy. So to close, I feel like we're in a very interesting position to help accelerate the future of automotive. For sure, like we've done in the smartphone area, it's really about working with a broad range of partners. I think we've done a lot of stuff already in terms of leadership in telematics, leadership in connectivity of the devices, driving all of these different technologies that are required. But we also are looking for feedback from the industry on new capabilities and new use cases that need to be built in. But I think in the end of the day, I thought this slide was funny because it's cars all talking to each other, and it used to be me going to cocktail parties and everybody saying, why are you putting all this stuff in? Because I just want to make a phone call. So life has changed. Thanks, everybody.
Thank you very much, Paul. That was fantastic. Our next agenda item is a panel of industry experts. We're really excited to have amongst us Chancellor Pradeep Khosla from UCSD, Patrick Little, SVP and GM of Qualcomm's automotive business, John Wall, CEO of QNX, and Brandon Nixon, CEO of LITS. We'll focus the panel's discussion around disruption in the value chain and what the future holds. I'd like to invite Chancellor Khosla and all the panelists up for this next discussion.
Hello. Thank you, Nakul, and welcome everybody. And please join me in welcoming our panelists. I'll say a word about them in a second. But before I introduce them, let me just tell you a little story where back in 1982, when I was pursuing my PhD, one of the first PhDs in robotics, and Paul was the other PhD in robotics at Berkeley, but about 10 years later, this vision was a vision that was going to happen around 2000. So 2000 came and went, and we were all very disappointed. But I'm so glad that we are here. And then there was 3 years I spent at DARPA, 94, 95, 96, managing autonomous programs, similar programs like this. And I think what we're seeing now is really technology which has taken over and is accelerating more than anybody had predicted. And this is not just because of the cell phone technology, we'll come to that in a second, but the three colleagues that I have out here have been leaders in their own industry where they're building components, they're building technologies that are further accelerating the adoption of our path towards autonomous vehicles, of our path towards next generation of intelligent machines. So let me say a little bit about who they are. So on my extreme left out here is Brandon Nixon, who's the chairman and CEO of Lytx, a local San Diego company. And he joined the company from Viasat, where he was a senior vice president responsible for the company's commercial business. But equally importantly, or more importantly, he's a graduate of UC San Diego. Thank you. And he also had the good fortune of being admitted to another nearly equally good school, Stanford University. So I have to just joke about that. Okay, it's a joke, okay? Don't call John Hennessy. Please don't do that. Okay, next to him is John Wall, who is the senior vice president and head of QNX Software Systems, and he's responsible for QNX software system strategy. And I remember QNX from my younger days when I was making an honest living, like building real robotic systems. And QNX at that time was the operating system of choice. It was a small company, really cutting edge operating system, cutting edge capabilities. So I'm so glad that.
It still is.
It still is, absolutely, it still is. Okay, and to my immediate left is Patrick Little, who has multiple roles at Qualcomm. He's dual executive roles at Qualcomm as Senior VP and GM for Automotive and Senior Vice President for Global Channel Management. And he's had an amazing career in the semiconductor industry. You name a semiconductor company, he's worked there. And he's served on boards of directors just like everybody else.
Not perfectly accurate, pretty close.
Pardon me?
Not perfectly accurate, but pretty close.
Pretty close, right? Approximately accurate. Okay, so what I thought we would do is have each one of them get up and talk about maybe no more than 5 minutes about where they see the future and how what they're working on is going to change everything. And then after that, we'll have a Q&A session. I'll start with a couple of questions that I have and then open it up to the audience. So you'll be thinking about what questions you want to ask. So let's see. I think the sequence is Patrick, John, and Brandon. Go for it.
Happy to kick it off. So what Paul doesn't know is I actually robbed a second nice slide from him before we even got started. So let's see how we can cue these slides up. So I'm just going to give you a brief, as we mentioned, just a couple of words on what the vision is for the automotive division at Qualcomm, and just kind of intersperse a few things that Paul perhaps didn't mention. This is the cool slide that Paul didn't get his hands on because I got ahead of him. So an amazing time in automotive. It's not boring anymore. It's not your father's automotive company or automotive industry anymore. What's happened in the coming 10 years will overshadow everything that happened over the last 150 years. The rate of innovation is just becoming absolutely amazing. The drive is for safer, smarter, more efficient, and very importantly, interconnected cars. You're going to go from experience where you're an individual cowboy driving your own car, rolling up the windows and doing your own thing, to being a part of a network of cars where you're talking to all the other vehicles and the infrastructure around you and getting access to the cloud to stream content and information and road hazards down the road. So it's all really changing. The two big drivers, obviously, are the connected car and then also the drive to autonomy, which is a very exciting but perhaps a longer mission. The other thing that if you meet with any of the automakers in the industry, the other thing that you obviously feel, particularly the new automakers, is the speed of innovation is going amazingly faster than it did before. So before we used to talk about life cycles of 3 to 5 years, and you would get a design in and you would wait and do some testing and then wait a little longer and eventually get it into production. Now the chip rate of innovation is amazingly fast. And it's bringing a whole bunch of challenges with it. One of the challenges, how can you deliver quality when the chip rate of innovation is like a third of what it used to be? So quite a few challenges coming along with this drive towards the connected car and this path to autonomy. So if the excitement of the mission technologically isn't enough for you, then maybe a few of these stats will help put virtue in the work. The first stat is 1.2 million folks die in cars, and as Paul, each year on the road worldwide. And as Paul said, 94% of those are human error. And so there is a pretty wide-held belief that if we move to autonomy smartly over the coming decade to 15, maybe even 20 years, we can save many millions of lives, tens of millions of lives over the coming decades. It's a pretty significant statistic. A lot of people are being killed and injured where it's not really necessary. The other element is we're just burning a lot of fossil fuels. It's 3 billion gallons of fossil fuels that just don't need to be burned if we could just path plan a little bit better and be a little bit more productive about our travel. And the reason is we just don't have a very far horizon. Our horizon is as far as we can see. Now things like V2X 802.11p can see maybe 100 meters. Maybe cellular V2X can see a couple hundred, 500 meters. But perhaps maybe a connection to the network can allow us to see 20 miles down the road or beyond. And so there's a lot of things that we can do to bring the immediate sensors of the car, but also the network, bring in all that information to more productively path plan, save a tremendous amount of fuel, dump a lot less emissions into our ecosystem. So there's a lot of virtue in our work, beside it being a really exciting path in bringing the connected car and bringing the autonomous car to reality. There's also a lot of virtue to the work of just saving lives and making our planet a nicer place to be. This is another trend that is undeniable. We get used to we look at this thing, I don't know, I would say hundreds of times a day on a light day, maybe more on a heavy day. And so the last thing we want to do is look at this thing, which is our frame of reference, so many times per day, and then get in your car and look at some little digital display and roll your window up. It's just a non sequitur that doesn't work for any of us. And so there's a huge drive to take that experience that we're experiencing in mobile and even much of the technology and move it into the automobile, frankly, as quickly as we can. And companies like Tesla and many others are starting to really understand that dynamic and move very quickly in innovating, bring a lot of these I would call mobile innovations into the car. A tremendous amount of new services, new business models are being developed. Frankly, the automakers are kind of scrambling to figure out, we can put a modem in a car, now how can that really add value to the consumer? And so this is a really ongoing dynamic discussion right now between the technology providers like Qualcomm and the automakers who are looking to modernize what it is that they're doing in the automobiles. And I will tell you, much of the time, they want to disintermediate the people between. They just want to be directly to the, talking directly to the to technology providers, so we can really brainstorm around what are the use models, how can we use technology to make it a better, safer, more productive experience for drivers. And then, of course, Qualcomm's job is to bring its technology war chest to bear to bring the autonomous mission alive and also to bring the connected car alive. I have to tell you, we're well down the road, and particularly when you look at our telematics and connectivity business, we have a tremendous book of business, a tremendous set of relationships with the automakers around the connected car for telematics and connectivity. Infotainment and autonomous driving is really leveraging our compute capabilities, which are many decades in the making. But I will say that it's becoming a very fun time around the industry, a very fun time around Qualcomm, working with the automakers, working with, as Paul said, the rest of the technologists and partners in the ecosystem to think really right to left. What is there out there for the user? Not just so much how can we sell the car for more, but how can we bring a richer, safer, more productive experience to the consumer? And so we're really having a great amount of fun. It's moving very, very fast, which I think is a definite advantage for a company like Qualcomm with the type of pulse that we have. And so we're looking forward to partnering with many of you to help bring autonomy and the connected car into become a reality. Thank you.
Thanks, Pat. John?
Thank you, Patrick.
That's great.
Hello, everybody. Again, my name is John Walsh. I'm the head of QNX Software Systems. I think everybody here in San Diego is pretty familiar with Qualcomm. So I thought that maybe I would give a little bit of an overview about QNX, if I know how to. All right. So QNX is a company that was founded in 1980, so it's been around a long time. It's a fully software-based company. We don't do hardware, we don't do devices. And our mission statement was to build the best real-time, functionally safe operating system in the world with distributed networking capabilities. And our primary markets in the day were military, industrial automation, telecom, medical. These were all areas where you needed functional safety and you needed high levels of robustness and real-time response. So you fast forward into the 90s and we start working with automotive customers to build infotainment systems and telematics systems. And at the time, those automotive customers, what they were looking for was very robust systems. They didn't really need functionally safe, they didn't need real-time response, but they needed it to be very robust. This drew the attention of Harman International, who bought us in 2004. Harman is one of the leading automotive tier ones for infotainment systems in the world. So it was a great relationship. We learned a ton about automotive. We learned, how to make them happy, how to have the right services in place, how to deliver to their schedules. We also learned that it's a very, very tough business. A car shipping with a hole in the dash is not a good thing. But finally, in 2010, we got sold to BlackBerry. And this is where our business actually took off because now our parent wasn't a competitor in our space. So while we talk about the operating system being the fundamental part of our product offering, we obviously have built all kinds of middleware based on our experience working with automotive. So we've built multimedia stacks, cellular stacks, Wi-Fi stacks. So Patrick talks about the portfolio that Qualcomm has of all these devices. Well, you need software to power these devices, and that's what we've been doing. We've even got acoustic suites for noise cancellation, hands-free in the car. Our whole goal has been to build vertically integrated solutions to allow the customers to get faster to market. As both Paul and Patrick mentioned, the innovation cycle is shortening. The 3 to 5 year cycle is not acceptable anymore. It's just too slow. So where do we see the future? So what we're seeing as an industry trend is we're seeing the consolidation of many, many ECUs in the car, 16-bit ECUs, 8-bit ECUs, into what we call domain controllers. In real terms, we're seeing this right now in the cockpit. People don't want an infotainment system that's distinct from a cluster, that's distinct from a telematics system. They want these things to be put together and consolidated. And so what you'll see is a car that has 60 to 80 ECUs will probably end up in the future having 10 or 12 domain controllers. Domain controllers will be a domain controller for LiDAR, radar, and vision, a domain controller for chassis, a domain controller for steering, braking, and other active parts of the car. And they'll all require very, very high processing power. But they'll also require having a functionally safe and secure operating system as the platform. So moving forward, we're developing now all the middleware for sensor fusion, camera vision systems, LiDAR systems, radar systems, so that once again, similar to what we did in infotainment that made us #1 in that market, is to create these vertical stacks so that the customers can sprinkle their secret sauce on top of this and not have to worry about plumbing. So one of the trends, I think Paul made a comment that I think is really valuable. Is the public being oversold some of the capabilities in the coming years? And I believe that they are. I really believe the trend is going to be to create much safer cars that will have lots of functions based on these domain controllers that will keep you out of trouble. But I don't believe that we will see fully autonomous vehicles in the sense of the Jetsons for many, many years. And I don't know about this big social change in the world. I think it's a few years down the road. And I really agree with Paul when he said that there's a danger of it being oversold. Thank you.
Hello, my name is Brandon Nixon. I am Chairman and CEO of Lytx. And given that you probably know us less well than you know the Qualcomm, I thought I'd do the same, which is to give you a background on the company. We're a privately held company here in San Diego. We've been in business for about 20 years. We are an IoT company before there was a phrase IoT. So we're very focused on the commercial world. So think big vehicles that are on the road a lot. And what we do is we have a sensor and a communication path and then a whole bunch of algorithms that are constantly monitoring the vehicle. We talked a lot about today, the speakers have talked about innovation and the pace of innovation. And it's really the exciting part is that it's happening along 3 different dimensions. So it's the sensors that are happening that are just going at light speed and the things that we're including into the vehicles. It's the communication path. So they just keep getting better and better. When we started in this business, we were transmitting over Wi-Fi because we found it very hard to transmit over cellular. And then it's the machine learning techniques and the deep learning techniques that there's just so much data that's rich these days that the ability for the machines to learn and adapt is what we've been doing for a long time, and we're taking advantage of a lot of the innovations that other companies are doing. We're privately held, 450 employees. We swapped out investors earlier this year. We were bought by GTCR, one of the largest private equity companies, for just over $500 million, making it one of the larger tech buyouts in San Diego history. We're up there across the freeway here. We grab data in 3 different dimensions. So we're sitting on these large vehicles. So think Waste Management, Cisco, US Foods, Greyhound Bus, San Francisco MTA, Swift vehicles. All of them have our sensors in there. And we're looking at 3 different areas. We're looking at what is the context of the driver, so what's the driver doing? What is the context and the state of the vehicle? So what technology is, what speed are they in, what's the state of the anti-lock brakes, those types of things. And then using machine vision techniques, we're looking at what is the state of the context outside the vehicle. So how many vehicles are out there, what's the closing speed, all of those types of things, what type of road we're on. We use all that to bring it back to our servers, and then we do machine learning techniques to provide it back to our clients, and they focus really on managing the drivers. We have 350,000 vehicles that are connected to the cloud right now. On average, we touch every inch of every road twice a day with a connected camera. By far the largest fleet of vehicles out there with connected camera. So what that's putting us in is this context of what's going on in the roadway. So let me put a little bit of Patrick's and Paul's big numbers into some context for domestic US. Every 5 seconds in the United States, there's a traffic collision. Every 5 seconds, right? Every 15 minutes, somebody dies on our roadways. Every 15 minutes. That's equivalent of a 737 going down once every 2 days and everybody on board dying. Right? Think about if the airline industry had that safety record. No one would get on a plane. I wouldn't. I'm always on a plane. Right? But it happens on our roadways, and we barely even notice. One of the big benefits, as Patrick said, one of the big benefits of pushing autonomous technologies is to try to remedy some of that. So all days are not like this, particularly for the commercial world. We're getting pulled into this whole world of transition, and it will be a transition. This will not be a binary function. It'll be a transition. And just think about all the problems that need to be solved between now and then. And it's a fascinating, fascinating time to be in it. We're pulled in to these kinds of conversations with a lot of the OEMs and to help them get through the movement to autonomous vehicles, which is a really interesting time to use our data, use our analytics, and use our camera technologies to go after that. The consequences. Think about limitations on technology, right? So the first one of these for Paul didn't work, right? The consequences in technology many times is it's a nuisance, right? Technology has limits, technology fails. The consequences inside a vehicle can be fatal. That's why the consequences of what we do is really, really important.
Thanks, Brandon. So, being a technologist, I'm really excited about what I'm hearing right now, but being a human being, I'm really nervous. So I don't know about you guys, right? So let me first start by stretching everything that you have said and ask you, let's start with Patrick. So fast forward 10 years. Are we still talking about 5G? Are we still talking about 6G? What are we talking about? What fundamental innovations are you going to make to transform this industry?
Well, firstly, I'm not going to fly after what I just heard. So I'm probably going to walk back to the Bay Area from here. That's a stat you want to hear after the flight. 15 years from now, 10 years from now, I still think that the primary drivers are going to be the connected car, connecting everything around you, being able to talk car to car, being able to talk to the infrastructure around you, being able to have access to the network, not only so you can do the fun things like stream content and give you information, but even so you can stream the information to know 10 miles down the road there's a massive wreck, divert somewhere else. I still think the connected car, we're in the very early stages of, in fact, I'll be honest with you, we talked to a lot of automakers who put the modem in their car. And then once in a while I ask, what are you going to do with that modem? And a lot of them don't really know. They just said, well, we know that it has to be connected, and frankly, we need the diagnostics, and frankly, we now know that we need the ability to over-the-air update the ECUs or the control units within the car. So they know that. But that's nothing that a consumer is going to pay for. And so they're still fleshing out their model of what does the consumer want with that modem? What type of feeds and speeds do we need based on the use models that the consumer is going to pay for? So I was mentioning earlier that this is a pretty compelling technology driver, not only at this company, but for all of us. And I think that in the 0 to 5, even 7-year horizon, we're still trying to catch up and align with this.
Right.
Like Paul said, he still puts it in the cup holder, and even though he's got this beautiful Tesla with a screen as big as the one above your couch at home, he's still fidgeting with this thing in the cup holder. So I think the connected car is incredibly central to this transformation in automotive, and I think that it's got a few years, maybe even as much as 7+ years before everybody figures out what's the real value that we can unlock.
Okay.
In addition to that, there's the path to autonomy, which is not disconnected to the connected car. Because for autonomy really to work well, you need that vehicle to everything sensor. You need to be able to look at the stuff around you, have access to the network. So I believe that connected car is the first big hurdle we're all going after. And then the path to autonomy within 10 years certainly will not be over. It'll be in a stage of kind of constant evolution. In fact, autonomy is an interesting one because there's a level 3. I don't know if you saw what somebody had a slide up there of the levels of autonomy. Level 1, 2, 3, okay, 1 and 2 were okay.
Can I ask you to hold? Let's come back to autonomy in a second, right?
Sure.
So connected car is what I'm getting from you, right? But let me go to John. How does your operating system change for a connected car, or does it change?
No, I actually don't think it does change. I think that there are certain aspects that have to evolve of the operating system and the platform. And so what we're seeing in the active safety autonomous world is, as I mentioned in my opening remarks, that we're going to have these domain controllers that will be handling aspects of the vehicle. And that will require high-speed communication within the car, secure communication. I think one of the things that people don't talk a lot about, or they do, but it's not as much emphasis is put on it, is the level of security that's going to be necessary. It's great to have a functionally safe software platform, functionally safe or redundant hardware.
Right.
But if you don't have the highest level of security, your car now could potentially be a weapon.
Okay, so we will come to the security issue in a second because that's a really important issue. But before I come to that, Brandon, your 18-wheeler, they scare me when I'm on the road. Does your technology make it any safer for me?
It does.
Is
Very
the
much
connected
so.
car connected to the truck and I'm in the middle of...
So, we are in the biggest vehicles in the world,
Right.
And they're always on the road. So they're in all the number of collisions that I talked about. They're around all that all the time. With the connectivity, if we just limit it to the connectivity, the power in that is on the vehicle, so much information is generated. I was told by one of our OEM partners that in a day, a Class 8 vehicle generates a terabyte of data, a terabyte. An enormous, think about that, in a single day, one vehicle. You can't pull all that information off. And so the connectivity allows you to make decisions on what stays on the vehicle and what comes off the vehicle. And when the information you can pull off the vehicle, you can make algorithms better and then bring them back onto the vehicle. So connectivity in all this is really key.
All right, so let's talk about software security, right? Even like when I used to do work in security, I tell people the only safe computer is the one that's not connected.
Correct.
Right? So now you've taken the unsafe element out, which is the human being, but you have created a different unsafe element by connecting the car, right? So can you guarantee security? And I put this in a context of when the fobs came out, people showed how I could take over your car and steal it just by
It's an attack surface, for sure.
right? So just let us talk, tell us a little bit about how safe should we feel?
Yeah, I mean, this, from our perspective, I talked earlier about functional safety, and there's specification for that. The ISO 26262 ASIL-D specifies procedures and tests to guarantee that your software is functionally safe. However, it really doesn't have any security. It assumes a system on its own. And so when you talked about what do we need to do in software, what do we need to change, back in 1980 when we were controlling a nuclear power plant, it wasn't connected to the internet.
Right.
It was a standalone system. Today, we do work outside of automotive for companies that create oil and gas equipment on the grid. They have the same concerns. These things are now all connected. and their targets. So we've spent a lot of time on the operating system itself and some of our middleware components, layering different types of security, but the security starts from the manufacturer of the part. Like if I have a Qualcomm 828.
Wait, I'm going to get to Patrick on that issue. So.
But it's establishing a root of trust, and it goes all the way to the connection
Right.
in the cloud. And it's a very complex topic, and you will need over-the-air software update because there will be vulnerabilities that will need to be addressed immediately.
So the root of trust starts with the hardware device, right? So talk a little bit about making chips more secure so that the OS doesn't have to do as much work.
So we have a lot of experience in making
I know.
chips secure, and it comes
Right.
from the mobile side of the house. So a lot of what we've inherited from automotive has already been developed for now almost decades on the mobile side of the house. So we're very familiar with how to ensure that the chip itself is secure and can be an effective root of trust, how it can handshake with other devices. We actually, John's a partner of ours. We work all the
I mean,
time.
BlackBerry is
We-
one of the most secure devices, and it's working
Right.
with Qualcomm
That's
parts.
right. And so we've been fortunate enough to inherit this from the mobile side of the house. And as I said, John has been a partner. QNX is a close partner of ours. And frankly, the most secure automotive systems that we do typically are with John's company.
Oh, I see.
And so it isn't, you're right, it isn't just a hardware element, it isn't just a software element. It's kind of working in concert to make sure that we have it covered. And frankly, it's the gift that keeps giving. So you constantly have to
Well,
keep,
we hope that, right? Because without that, it's going to be a real problem. I think we need a lot of security in these systems.
a lot of
I hope
people
you
with
guys
time on
are
their hands.
thinking about questions. I'll come to you in a second.
So
Yes, sir.
I mean, put security into my world.
I know.
Just think about how important this issue is when you're working with fuel hauling vehicles. You know, just think about what happened last week in the bomb in New York City, and just think if someone that is crazy like that gets a hold of a fuel hauling vehicle and can automate it in an automated way, drive it into the middle of Manhattan.
It's a weapon.
It's a huge weapon.
Yep.
And so these kinds of things are enormously important to the rollout of autonomy.
So I see questions. Let's go with you, sir. Wait, there are microphones out there. There are mics. Where are they? All right, let's go with number 1, then number 2, number 3, 4, 5, 6. Okay,
All right.
7.
So question, we talked about connected cars, and the problem I see is unless all cars are connected around me, it's useless for me to pay for connected car whenever that happens. And to make it happen gradually without any other entity like government or anybody is going to be extremely difficult, because you sell first connected cars which
pose
are
a
2 miles,
question?
which are 2 miles apart, and then what's the point
Right.
of
Yeah,
using
yeah.
that? So the problem is who will pay for it if
yeah.
the first few buyers will not pay for it, so who will pay for it?
It's a good question. So the role of the regulator is pretty important, because particularly when we were talking about cellular V2X a little earlier, if you don't have a structure, a trusted structure for everybody to build upon, then no one's going to make the investment. You'll end up with these heterogeneous approaches to the problem. So the role of regulation cannot be understated. For example, DSRC is likely to be mandated, which is Wi-Fi based V2X.
So can we talk about regulation in the trucking industry, which is regulated twice now?
Yeah, so it's been regulated, almost since its history. And right now there aren't regulations on a variety of things other than what the driver is doing, and they're very focused on that, and they do a very good job of monitoring that. What Patrick is talking about is there can be some things that can push technology into the industry faster, and critical mass items like what you're talking about can be one of them, and it can help both in the consumer as well as the commercial world.
Right, so for added reading, yesterday, September 19th, the most famous man on this earth wrote an op-ed piece, and the most famous man is Barack Obama. Self-driving, yes, but also safe. It showed up in the Pittsburgh Post-Gazette of all places, because that's where Uber inaugurated its autonomous driving car, right? So it's actually worth reading. It doesn't address the issue, poses the right questions. 2.
Okay, so my question to the panel is, you all stated that the LTE network or 5G networks need to be around, right? But at the moment, the operators are still struggling in their business model to densify the networks. So how do you think the vehicle is going to be a platform to be able to change the densification you need? Because at the end of the day, the operators cannot make enough money to build out those networks that you guys need.
It's a good point. No, it's a really good
So
point.
what is needed in the car, do you think?
It's a very good point. And so a lot of data is going to be pushed through the car. And honestly, every operator we talk to is incredibly excited about the monetization opportunities in the car. And you've probably read some of these articles that say more than 90% of the machine-to-machine data is going to go through the automobile. So they're all champing at the bit, quite frankly, to be able to get to the car as a platform for new business models, new services, streaming. And even if you go towards the infrastructural piece, where who's going to put in the infrastructure in the roads, many of them are looking at that saying, hey, maybe that's an opportunity for even a cellular operator, because they have a business model that allows for more investment there. Actually, I think one of the bigger challenges is to get the typical roadside unit guys to put cellular or Wi-Fi technology into their infrastructure. That's a tougher sell.
Just to carry on that, I mean, I know, I'm from Canada, and part of the discussion we're having with government is does this become part of the government's infrastructure spend? Because this is something that's going to be, so instead of stimulating the economy by building bridges and building the traditional brick and mortar infrastructure, that they should start investing in tech infrastructure. And maybe this is something that's a shared government responsibility if we're going to see this become a reality.
Right.
Because if you leave it only to profit and loss, you're going to have high densities in places that make sense, they can make money, and you won't in other places. And that's the reality of it. So you do need the government, I think, to be involved.
So I can tell you how we did it. So we started our business when the pipes were pretty small coming off the vehicle. And so we went to a distributed decision model where we've got algorithms that run on the vehicle, and then we got algorithms that run on the server on the other side of the communication link. And they're updated nightly on the server, and then occasionally they get updated onto the vehicle. We make decisions on when it's in coverage. That's when we'll bring data off, but it's not in coverage. It has to be able to do its functions without the connectivity.
So what about the role of truck stops and other stops to transmit high-density data real fast as the car is going past or the truck is going past?
Certainly going over the Wi-Fi, any Wi-Fi network is cheaper than going over the cellular network.
Right.
And so if you can figure out small pipes, fat pipes, and then free pipes, you got the best of all worlds.
Cool. Number 3. Yes, sir.
So we're looking at a nexus of control domains, the utility sector and its SCADA, the transportation operating centers and their network of control domains. And then if you look, for example, at FCC, how is it that we're going to agree to get along among these different, I would say, policy and regulatory bodies? And what does the overall OS look like?
That's where we hand it over to the DoD to manage the spectrum. Who wants to take that? Okay.
Herding cats.
I think, in a test, like you have to answer 5 out of 7 questions. That was number 6. So
I'll throw out an answer. So as an engineer and a technologist, it puts me in a weird position to make this statement, which is the autonomy world, right, is one where technology is going to be able to do absolutely amazing things. There are non-technology factors that have to be figured out. Regulation is one of them. The insurance industry is another one. The laws are, that op-ed that you're talking about by President Obama, the laws of who regulates what a vehicle can do are controlled by the states, right? What they're trying to do is they're trying to make it so that the autonomous function of the vehicle is controlled by the feds. So now you have a situation where you've got federal regulation on when the vehicle's in a certain mode and state regulation when the car is in driver mode. It's really complicated. All that stuff needs to be figured out, but it's going to be figured out at the same time the technology is improving.
let's go to 4.
So Paul mentioned something about machine learning. I was wondering if the thought process is whether it would be actually connected to the vehicle or the driver. As an example, if I drive a car and I'm comfortable getting very close to the machine in front of me, that feedback loop, is it connected to the driver who's driving the car, or is it actually to the vehicle?
It's to the vehicle. And so you'll have a variety of sensors around the car, LiDAR, radar, what have you. That will come to probably, most likely, a central compute engine, or a high-performance centralized computer, let's put it that way, which will make quick decisions about what to do. Now, over time, machine learning will allow the perfection or the evolution of those decisions. And it's going to be mostly based on the car. Whether or not you can personalize that and say, hey, I don't mind platooning. Personally, I don't like platooning. I have somebody in my family that platoons pretty often. Makes me very nervous. But it's an interesting question about, will they allow personalization? It's likely to be more rules-based because it's based on, remember, you're part of a society, you're part of a network, so you may be more aggressive. But my guess is that it's going to be mostly based on the car and mostly rules-based. It will continuously improve, but may not take on your risk profile, as an example. That's my best guess at where that goes. Really good question, actually.
Yeah, but it certainly needs to be adaptable. And what the granularity of the adaptability is really the question. So if you looked at when Uber put the autonomous fleet in Pittsburgh, one of the things they talked about is the state of the technology right now is that it could not make right turns, but it also couldn't do the Pittsburgh left. Right? The Pittsburgh left is when the light turns green.
There is no such thing.
Well, that's what the articles I was reading. But the Pittsburgh left is when the light turns green, the first car that's in the left turn lane gets to go before the other ones go straight. Well, we don't have that rule in San Diego, right? So if the autonomous vehicle is going to be in Pittsburgh, it's got to be able to do it.
So here's a little tidbit that I want to share with you. So in 1995, 1996, there was an experiment called Hands-Free Across America, the first autonomous vehicle. It went from Pittsburgh, Carnegie Mellon, to San Diego, right? Amazing. Here it is, 2797 miles out of 2849, like 98.2% hands-free. And this was the first experiment where autonomy was the only goal. We look at where we are today, and autonomy is just taken for granted, and the goals are way bigger than autonomy, right? Okay, number 5, and then number 6, and then there's number 7. Wait, did I miss you? You were 5? You were 6. Okay, so now it's 5, 6, 7, 8. Whatever 7 was became 8. Yes. Sorry about that. But go ahead.
So this conversation is bumping together two technologies that go at completely different pace of change. The average vehicle, given the fact that I have a smartphone and its technology, is 11.5 years. Mobile phones are exchanged about every 18 months. What's the architectural challenge of having a platform from an operating system, from commercial trucks that aren't swapped out every 18 months? How do you architecturally move at a pace of change where the communication channel, the sensors, are not changing at the rate that the semiconductor world can drive it?
Yeah, so I think that's the challenge that the OEMs face today. I mean, if you look at an OEM planning a 2020 car today, it's in planning right now. Decisions are being made right now about what will be in that car. I think this is a challenge for all of us, and I think that one of the ways that we can improve this situation, right now, if you look at a car, I talked about the hundreds of ECUs or the 60 to 100 ECUs in the car. They're all produced by different tier ones. This tier one isn't talking to this tier one about how to make this better in the future working together. And this is why I think there'll be a move to this domain controller concept where you'll have a lot more consolidation of the functions, and the OEM will have a lot more control of these platforms. I think moving forward, if the OEMs could get together and kind of come up with some standards of what these look like, this would allow upgradability of the car at a much more rapid pace. But one of the things that I see as a challenge for autonomous drive is, what do I do with current cars that are on the road? So I build a car in 2020 or 2025 that's autonomous, but I still have people driving cars that are 20 years old, 15 years old, with no autonomous or no safety functions. Are we ignoring these cars? I mean, these things are all going to have to coexist together for, I believe, a long time before everything comes together. For me, the full autonomous, the car comes to my house and picks me up and brings me wherever I go. I mean, I don't see that for 25 years. Okay. That's my view, my opinion.
So let's see, that was 5. Wait, 6. You were 6 or 7?
I should just say one mention. I want to follow up, if I can, quickly on your question. So it's a great question, by the way, because the time constants in automotive are very long. So we launched our flagship product in the mobile world just this spring. That same product is very quickly going to be available to the automakers, but they take a couple of years to get it into production. So from hardware, we're doing everything we can to compress the cycle, the phase shift between mobile and automotive. But also software has a big piece to do with that. Over-the-air updates, keeping it fresh through software. And then we've even come up with modularity schemes for hardware. Automakers have different opinions on how much they want to upgrade the hardware, because that'll keep you in that Pontiac for for a decade. Maybe they don't want you in that car for a decade. But there are hardware and software schemes that can come together to keep your solution pretty evergreen, and kind of move along with the changing network, particularly in the city.
And that's a very good point. I mean, the car makers are looking at more pluggable cartridges and modules for different pieces. I mean, it hasn't reached body control or chassis control, but certainly for infotainment and for navigation and for telematics, there are a lot of initiatives out there where you will be able to go to the car dealership and buy a module.
Right, so that's what somebody who drives a Tesla said in the last 2 years. She was telling me the car she bought is not the car she's driving, even though physically it's the car she's driving. But otherwise she's not. So who's 6? Okay, 6, 7, right? Okay, 6, go for it.
All of you have told a fairly optimistic story, albeit with challenges about where your businesses are going, and certainly your businesses seem to be in the right place, and given where the technology is going. Can I ask you to put yourself in the shoes of the OEMs, the automakers, and sort of the because this was built as disruption, and this is all good for you guys, but those guys are really struggling with how do we deal with all the stuff you guys are throwing at them? And then you throw in predictions like that, anywhere from 40% fewer cars to 70% fewer cars 20 years from now, 30 years from now, depending on who you believe.
Okay, question. We got 10 more minutes.
So can you put yourself in the shoes of the automakers and talk about because some of them will die, some of them will succeed. What are you seeing at that level?
I'm happy to field
Go for it.
Yeah, go ahead.
Yeah, so I'll tell you, I guess we could both cover that equally well. We frequently talk to the automakers worldwide. Some are enjoying the transformation because they think they can move quickly, and others, I think, really have a gut-wrenching experience saying, we're used to measuring twice and cutting once to perfect quality, and now we don't have 4 years to get a new product to market. We have a year and a half, 2 years. And so some of them are relishing, guys, you know who, I won't mention their names, but the ones that feel that it's a distinct advantage for them to move quickly, they're doing incredibly well. And there's others that are just having a tough time getting out of their own way, because literally over 100 years worth of this ingrained in their DNA, delivering quality at speed. So it's a challenging experience for the automakers, but quite frankly, I think, honestly, for Qualcomm in particular, it's bringing us very close to them. They want to get the others intermediaries out of the way so we can really have a good technology discussion, and they look for us to accelerate.
So at what point do you take over and get them out of business?
No.
Just 7.
I'm assuming that question wasn't for me. And
7 here. I wanted to thank you and Qualcomm for an outstanding presentation, but I've got 2 questions. One is the FCC apparently was having issues with the cellular want a bunch of bandwidth back that was allocated for transportation talking between the cars. Is that resolved at all? And the other question is, does the Tesla that has an LTE connection allow for an SS7 hack to occur?
I think it's probably SS7 is probably a good question for you.
No.
So I don't know about...
Okay, on the regulatory issue on the FCC about the spectrum issue, I don't know. I'm not entirely familiar with that particular issue, so I can't answer it. Maybe one of the other panelists.
No.
Has.
I'm sorry, what was the other one about?
Well, the SS7 thing has seems to be a security deal about it. As far as I know, Tesla's the only car that's actively connected.
So let me tell you a little story, right, about computer security. Like I said, number one, the only secure computer is the one that's not connected. About 10, 15 years ago, one of our big software tycoons thought that his system was extremely secure. So I think he put like a little big sign on 101, Oracle 7.0, like unpenetrable or something like that. Within 24 hours, it was broken into, right? So the point I'm trying to make is, my panelists may not be wanting to answer, but to believe that anything is 100% secure is a mistake, right? So the only question is, how fast are we going to be ahead of what we think are the security flaws?
Identifying vulnerabilities and
exactly.
patching them.
And being on top of them, right? And that's why I think this whole notion of this 18-wheeler being a little 747 ramming into a building is a good analogy, because really, if somebody takes over, they can make the 18-wheeler do whatever
Security
they
is
want.
a huge issue.
It's a very big issue, and that ties to liability. We'll get to the liability. Okay, so number 8 now. Yes, sir.
Yeah, Gary Rayner, I'm the founder of DriveCamlytics, and my question is around data collection. We're all aware with the Snowden revelations of the data collection programs that have been mandated by the federal government. As we look at privacy issues and as that relates to potential law enforcement, for example, these automated systems that have cameras that can view the road could potentially look at vehicles that are breaking the law that are maybe not autonomous. You're thinking about things like Amber Alerts, where you could be identifying every vehicle on the road in real time and reporting that back. There's various reasons why people may not want their location tracked. Some of them would be criminal and some of them would be personal. What do you see as the big issues around privacy and law enforcement and data collection?
That's a great question. Who wants to take over? Actually, truck drivers care about it a lot.
Yeah, so we spend a lot of time. So we are a worldwide, Gary, nice to see you, by the way. We are a worldwide company. We have offices, obviously in San Diego, but in Toronto, in London, and down in Australia. We have fleets across the entire world. The privacy laws, which is what Gary's talking about, are different around the world. And so some of the information that can be pulled off of vehicles in certain countries can't ever leave the boundaries of those countries, right? And so for vehicles to be able to be deployed around the world, they've got to comply with all the privacy laws, and the privacy laws change all the time. So you talk about another sort of non-technology factor that needs to be figured out to make this world a reality, that you add that one to the list.
So why would that be any different than computer privacy laws, except that there's more data in there? But isn't it very similar to computers on wheels or computers?
Let's say you're taking a video outside the vehicle and you happen to pick up pedestrians that are on the side of the vehicle.
Right.
And there are privacy laws in certain countries where you're not allowed to take any video of anybody that isn't without their knowledge. Right? And so if you take that video, then it's against their laws, and so you've got to comply with that stuff.
Oh, I see what you're saying. Okay, so before I get to you, so let me just talk a little bit about, so in the mid-90s, there was this great thrust about creating liability for software companies because the regulators thought that software companies, it didn't make sense. They were making so much money, they didn't have liability. And the analogy was the car industry, where the car industry had significant liability for any malfunctions, right? Here we are now, the car and the software industry has totally converged and the software has taken over. Let's talk about how we feel about creating liability laws for cars that are basically software platforms right now.
Yeah. So I'll take that one in the commercial world.
Yeah.
So in the commercial world, if you get over a fleet more than 350 vehicles, they typically self-insure. And so all of the collisions that occur go straight to the bottom line of the companies. And so they're very focused on managing that, which is how we've built our business, is to help our clients manage their claims cost and keep their drivers safe and keep the community safe. If you think about the move to autonomy, right, there's been an insurance industry that has been developed over 100 years, right? Along with the buildup of the automobile, the insurance industry came along with it. As you go toward the vehicle in control, not the driver in control, all of a sudden the risk gets transferred from normal insurance to product liability. That, again, is another one of these transformations that needs to be figured out before this world that we're talking about is a reality, which for most of us that study this stuff, that's why we say this is not some binary cutover from driver straight to autonomy. It is a transition. And the transition has got to live in the world of lots of things changing at the same time.
So does the risk, is it shared across the supply chain or is it only at the OEM?
Well, so this is something that we're living today. And is to go back to one of the questions that was asked, are the car makers overwhelmed by this technology? And as Patrick mentioned, some of the car makers are embracing this. I went to a car maker who shall remain nameless, but they put up a slide for me that said, car maker, a motor company, and their next foil they put up was, the name of the brand, software company. And they are embracing this. They're hiring software developers. They're going to own this technology. They're going to own the secret sauce to autonomous drive. That's their mission. There are other OEMs that are going to do the same thing. The problem with the liability is the OEMs have a history of, I buy a product from this company, I buy a module, that module has a warranty, and that tier 1 is liable if I have a recall or I have a failure in the field. They're looking to use the same model with various software vendors who have a much smaller stake in the business, yet they want these software makers to take the same amount of liability. And it's to the point, if you speak to an insurance company to give me liability insurance, if you say it's for autonomous drive vehicles, they won't insure me.
Right.
So it's a very tough negotiation right now. Where does, ultimately there will be a liability, but who's picking up the majority of that liability?
So if you believe that, then I think there is a whole public policy angle and some education and awareness of our lawmakers that has to happen, because the last thing you need is a bad law coming into play and then killing a whole industry or creating bad outcomes, right? Let's go to number 8 out there. Yes, sir.
I should add one point on the liability. The other thing that's is difficult is it's a collaboration to get an autonomous solution to market. I can't say, I'm going to take a module from John and take a piece from Patrick, and those guys will share the liability. There's a fusion going on, and at speed, by the way, as well. We're doing it very quickly. So it's very difficult to peg liability on a particular supplier in a linear supply chain. It's more of a distributed thing. So now it's much more difficult to say what share should each entity own. So it's one of the bigger, I would say, in terms of disruptions and challenges, it's one of the bigger.
It's a big issue, right? We'll take 2 questions. Yes, sir, and then you will be the last one.
All right. Within the last week, the federal government issued 15 new regulations on autonomous cars. Have any of you had a chance to review and assimilate what effect that's going to have on the progress?
Anybody?
We haven't looked through the list.
I'm sorry, that was not taught in the class, so we didn't look at it.
I can tell you that we haven't looked at the list. Maybe some members of the team have looked through the list, but we have very frequent interactions with all the government agencies, all the municipalities, the auto OEMs, the tier 1s. We're pretty familiar with where the boundaries of autonomy are going to lie. So I think that, and you're going to see a lot of this. I think you're going to see increased regulation as we move. I just want to remind everybody, there's a balance between measuring 15 times and finally cutting once and losing the 1.2 million lives every year and moving a little bit quicker. So there's that balance there. If we could wait 20 years, but just multiply that by the million per year people that we're losing and people that get injured, they're starting to pile up. And so to me, there is a balance of risk reward there, and we should try to move quickly. Now, again, I was mentioning earlier on autonomy, that autonomy should be an analog scale. Right now we have informational ADAS, where when you do something like leave your lane, it'll just flash to you and say, you're still in control, but hey, get back in your lane. Later on, it's going to move to level 2 and eventually. Level 3 is the tough one, because that's the one that says, okay, the car's driving until it gets tough, and then we may pass it back to you. So, but that's the part where what are you, eating a sandwich at the time? You're driving along saying the car's got it, and then all of a sudden at level 3, it can immediately say, okay, now you must take the wheel. And so that's why an argument for this analog introduction of autonomy is going to be challenging, because that middle level 3 requires machine driving, full human awareness. And if you're not driving full time, you're likely to divert your attention to other things. And then all of a sudden, you're in control.
Let's do one more question right here.
I think Patrick just maybe answered part of my question, but my question was really around the rollout of the community of cars that are they can drive, the driverless cars, because the way I look at it is that if going back to a point, there are set rules and all the cars are following the rules, then that community would work really well. But if you have 4 cars that are talking and following the rules, and then you have a human car that doesn't know what the rules are and kind of disturb that system, so it might cause some trouble. So I guess is the vision to have maybe start with small cities and have them all convert to basically cars that automated cars, or because again the gradual model I think would probably not be a good replication.
I think a different way to think about it. Would we keep on driving like Americans do, or would it become like driving in Bombay?
If you've been there, you know what I mean. Well, I will tell you this, that it will most certainly be a hybrid, because those people that have a certain car that they love, I happen to be one of them, I'm not going to stop driving down Highway 1. Maybe my son will. Maybe my son will say, ride sharing, I get it. Why do you have to own the thing? You can just...
Motorcycles, we're not going to get rid of motorcycles tomorrow. I think it's going to be, level 3 is going to be a big transition point that will be over a long period of time. There will be, I think in the immediate future, we can save lives. I think by having active safety systems as opposed to passive safety systems. So if you are pulling the car into a blind spot, there's a car in your blind spot, the car will pull you back into the lane. I think that's right around the corner. That technology exists today. But the step from that to cities that are fully autonomous, I think that's going to be much more difficult, mainly not because of technology, but because of all the topics we talked about, legislation, insurance. You know, are we going to tell people that don't have a lot of money that they have to get rid of their car and spend a lot of money on something newer? That's just not going to work. So it's going to take time.
It's also like to be situational dependent. So it's fairly easy to automate a vehicle on the freeway that has really good lane markings until it snows, right? And then it becomes a lot more of a challenge. So in good weather on the highway, that'll be the first thing that gets automated. In stop and go traffic, all they have to do is follow the vehicle in front of them. That's fairly easy. Off-road, in dirt roads, it's fairly easy as well. So you see a lot of the autonomous technologies going into, just off-road applications like oil and gas applications. There's so much money being thrown at this problem right now that there are going to be incredibly interesting technologies that come out of it, regardless of where it goes.
You made a great point. I mean, something that we're working on actively today is heavy machinery in mining. That's going to be autonomous in the next 3 years. Because it's bounded, it's well known, they understand it, there's no people's lives at risk. So in those types of situations, it's no problem. I live in Canada. LiDAR works great and provides very accurate images, but you start having snow, you have ice on the road so you can't see the lines. I mean, these are big challenges that are tough to overcome.
Patrick?
I'll end it with a story. So I went to CES this year, and I saw a car that was saying that it was part of the autonomous curve. And so what it showed you is it showed you the steering wheel, but then it folded in half and went inside the dash and went away. And the driver's seat turns around, and any one of us would just pucker immediately and say, okay, that makes no sense in my brain. I told my 11-year-old son that, and he said, that's very cool.
That's very cool.
Okay, so that's kind of, maybe it's going to take a whole new group of cowboys to move into this, where they say, hey, that's something I can fit into my worldview.
So I have to tell you, in the context of IoT, I was just getting used to the fact that my refrigerator will start ordering milk when it thinks I have no milk. Now I have to worry about my car. With that said, please join me in giving our panel a big hand. I think they were great. So as you go out, be confident that there's a whole lot of exciting stuff happening, but we have great technologists, great companies out here who will make sure that the future is bright and along the right direction. So thank you very much.
Good job. Thank you.